Hello, I am Bhargavi Shaha. In this video, I will briefly present my research on nonlinear dynamics of inflation and reheating in the early universe, which I developed during my PhD days in IIT Guwahati. Inflation provides a compelling description of the early accelerated expansion of the universe. However, this phase must eventually transition into a radiation dominated state to match the standard cosmological evolution. Understanding this transition, known as graceful exit, in a fully dynamical way remains an long-standing important open problem. In this context, my work focuses on understanding how radiation is generated dynamically, how energy is transferred from the inflaton field to radiation, and whether this transition can be achieved in a self-consistent manner without introducing additional assumptions other than slow roll assumptions, which I have used only for finding the initial conditions. To address these questions, I study the coupled nonlinear evolution of the inflaton field, radiation energy density, and the Hubble expansion of the universe. These components are evolved simultaneously, allowing a fully dynamical treatment of energy transfer from inflaton field to radiation. An important aspect of my work is the inclusion of back reaction, ensuring that the interaction between the inflaton and radiation is treated self-consistently. The system is solved numerically because analytically it was impossible to solve. So the system is solved numerically using computational methods implemented in Fortran and Python. I myself developed a code which could do this successfully and solve the graceful exit problem. Within this framework, I follow the complete nonlinear evolution from the inflationary phase to the radiation dominated epoch. This approach allows me to capture the interplay between expansion, radiation, production, and the energy transfer in a consistent way. I have applied this analysis to both cold and warm inflationary scenarios to check the graceful exit in both the scenarios. The key results of my work are that radiation production begins dynamically during the inflationary phase itself for cold inflation. Although it remains subdominant initially, it grows steadily during the evolution. Near the end of slow roll, radiation becomes dominant, leading to a smooth transition to the radiation dominated epoch. This provides a natural realization of graceful exit. I have demonstrated this behavior in both cold and warm inflation scenarios. In addition, my work on alpha attractor E model shows consistency with observational constraints in warm inflationary scenario. Overall, my work provides a self-consistent dynamical framework for reheating. It clarifies the role of back reaction and energy transfer in shaping the transition. These results help establish a clearer connection between early universe dynamics and the subsequent evolution of the universe by matching the reheating temperature of the early universe. Thank you.